Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Topics in the wider sense. He's going to give an overview of a bunch of different projects that are taking place at the Darmstadt University of Technology right now in his group. Some of them around mobile devices and different topics, so don't want to anticipate that. And I think we need to give extra credit for him today because he tried to give the presentation on prototypical handmade software, which then...
Prototypical handmade software. This software runs in different universities on a daily basis.
Okay, so sorry for getting that wrong, but obviously it's still something that's more challenging. I always think it's pretty impressive when people do that. So I think we should just get started. So thank you very much. And
thanks, Pat, for the introduction. In fact, I do think it's best to make this presentation a rundown of the things we're doing, and then if interest comes up, we got lunch in the afternoon for doing individual talks about things that might interest you in your individual projects and topics. Nevertheless, I'll spend some 10 minutes to give you a kind of introduction to our vision of ubiquitous computing in order to share the broader scope of what we're doing and also the mindset that we have that might be debatable, but might bring some new insight into the areas that you're covering too. So in general, in my group, we have basically two branches of research. One is ubiquitous computing, and that's what I'm going to talk about mostly today. With a background in multimedia and distributed systems and networking, we focused on development support for all kinds of applications that you would find in future ubiquitous computing environments. The second branch that I'm not going to talk much about today is on e-learning. And there's a number of other additional activities that I'm involved in. This is kind of the setup that of the group that I'm heading, about 25 permanent staff plus PhD students in addition, and of course students, graduate students, etc. Now, as I promised, just a few minutes on what are the challenges in ubiquitous computing. And we see a focus on smart everything these days, smart batches, smart labels, smart rooms, smart spaces, smart logistics, smart places, and so on and so on. So things get interwoven with the environment, that's what we know, and we have ambient and smart appliances everywhere. And we see this happen, and there's a big race to come out with the ever smaller, ever smarter gadgets around the world. And I definitely don't worry about these things going to happen. What I worry about is, are we going to be able to make this a really integrated environment? For example, in what we call the real-time enterprise. Real-time enterprise means that the digital model of the enterprise and the reality out there usually have a gap in between, a gap that you have to bridge manually by inventory and manual data entry, and a bridge that has also a time gap between something going on in reality and the enterprise software realizing it's going on. So making this gap close up is a major endeavor and involves integrating many parts of the ubiquitous computing world to make it one well-integrated, really intelligent system. On an even larger scale, we figure this world of ubiquitous computing, of ambient displays and interfaces and ambient devices all around, some of them also worn and taken along in the mobile space. And again, figuring out a free economy of services in such an environment where all the devices, but also all the software pieces and components would nicely work together is something that we haven't really sorted out yet. So to summarize, the major point in ubiquitous computing is a point of making integrated systems happen. Like all the new challenges, you find that they are rather interdisciplinary. So many traditional computer science disciplines come in and have to join and have to make improvements in order for this to happen. And so you could say ubiquitous computing is basically everything in computer science plus the HCI-related issues and other border issues of computer science. Everything combined, that's ubiquitous computing. And of course, that's not a way of looking at it if you want to set up a research program or something. For that purpose, I try to summarize the major challenges and categorize them some way. And that's the last general slide I want to share with you. And in order to categorize them, I came up with this acronym called SCALE, because in fact the first letter S stands for scalability, and that is a major issue in making ubiquitous computing happen. From today, some 1 billion devices on the internet, to tomorrow, every person in the world having a internet connectivity, so maybe some 10 billion devices in the future, to machine-to-machine computing, where we're talking zillions of devices talking to one another without human interference. There is still some scalability, orders of magnitudes to come that we have to cope with. And the current move from client-server computing to event-based computing is one of the issues that helps here, but more smart distributed computing paradigms have to come up, and we have to learn from what nature brings into being, because we're reaching that complexity. So taking in from bionics and socionics is one more aspect that one might consider. Having things work on a global scale also means having enough standardization and in a much more dynamic way than we had in the past. So everything around ontologies, self-describing services, and so on is also important. The second letter C stands for connectivity, and here I go well beyond the current focus on wireless communication technology. Of course, this is a basic enabling technology, but managing the connectivity of these zillions of devices in an intelligent way demands many more approaches that are on a higher level and where we still don't have the appropriate architectures to cope with. The maybe most well understood or well researched area in ubiquitous computing is that of adaptability, both on the user interface side and on the application side, where we want to use context awareness, understanding the current situation of usage in order to target the human-machine interaction and the operations that are available and make sense in a certain situation. I used the term liability as the fourth major challenge, for one, because it fits nicely with this acronym SCALE, but also to indicate that I think it's more than IT security today. With ubiquitous computing, we're facing a number of challenges that go beyond what we have found in this IT security discussion in the past. One being that we have to be able to work in an infrastructureless mode, that we have to provide ad hoc encountering of devices, that we have to understand what trust relationships mean, and maybe the major point, that we have to concentrate on the balance between security and privacy on one hand and responsibility on the other hand. Because this is in human communication and human cooperation and in social sciences, this is a major issue. How much do you want to protect the individual to live his or her own life, and how much do you want to be able to hold somebody responsible? For example, if a service is used, the service user wants to have guarantees about what he gets and only pays for what he gets. On the other hand, the service provider wants everything the service provides to be paid for. If there is fraud or illegal action, we want to be able to break the privacy that we had in the past. And this balance may develop in different ways in different civilizations, in different countries, in different cultures. So we want to build software that copes with these different developments. For example, in Europe, people may have a different perception of how much privacy they want, how much they want to give up privacy in order to have better services. And this whole culture, this whole notion may lead to different legal implications in Europe than in the US, in Asia than in Europe, etc. And now how do you build software that has a lever where you can really balance between responsibility and privacy, for example, and make that happen? So again, a number of issues that we have not really properly addressed in past IT security research that comes up with ubiquitous computing. And since the 1990s, when Mark Weiser coined the term of ubiquitous computing, he put this issue of ease of use, proper user interfaces in the center. And in fact, I don't want to blame Microsoft in these holy houses, but we can all imagine if we are surrounded by 100 devices and they all end up with blue screens and they all demand keyboard entry. This is not the way we want to interact on the move with little attention with 100 devices. This is okay for a desktop setting, but not for an on-the-move ubiquitous interaction with devices. And either we're going to solve this problem, or ubiquitous computing in the vision of Mark Weiser will never happen. So this is really another very key issue to solving the vision of ubiquitous computing. And in fact, as you run down this list, you'll see that each one of them is a killing characteristic of this future vision. And if we fail to provide one of them, we'll basically fail with the whole mission. Okay, this ends my part of the talk. That's about our vision and our mindset. Okay. From this, we developed a visionary architecture that we are working towards and for which we are providing components now. This visionary architecture seems a little bit mad in the beginning, but let me explain it to you. And then as we realize this vision and architecture, you'll see that the things that we provide on the way there really make sense. This future vision of ubiquitous computing is centered around a very small device that we call the minimal entity, or me. We strongly believe that in the future you'll not have gadgets all around that are all equal. We believe that since you're doing more and more things with the internet, with the network around you that have legal impact, you will want to have one entity that you can really trust, that represents your digital identity. And in fact, we could even have that today because we have more than 500 million users of GSM phones, and they have a pretty decent implementation of a secure digital identity. But this is not going to open up to the public internet use, so forget it. We'll have to, quote unquote, reinvent the wheel, do it maybe better, and come up with something that is minimal, that we always carry along, and that represents our digital identity to the surrounding. And the big question is, what would you want to have in this device that you even take along to the soccer game because you want to go through a security gate, buy a can of Coke and all that, so you really want to have it with you all the time. What is it that goes in there? Obviously, processing memory, networking, secure digital identity, and even some context awareness maybe. And hopefully we're going to miniaturize that to just an earplug. So in the center we have this minimal identity, and we have focused our research on these minimal identities to be very voice-centric. I'll get to that in a minute. Around that you have all the gadgets that you use. Today you go to work, so you have your tablet PC with you. Tomorrow you go on a business trip, so you only have a PDA and a digital camera. So these are things that get associated with your minimal identity, so they again become part of what you represent, what you use, and this is automatic. So we call these things the user associable or just us kinds of identities. On your move, you encounter things that are embedded in the environment. Let's call them smart items of all kinds, or IT for short. And sometimes you're able to personalize these, to grab a tab on the table, associate it with you, so the it becomes an us, and you have full control over it. Sometimes you find something in the environment of somebody else, like a digital camera. Pat might have a digital camera. I say, hey Pat, could I take your digital camera for a moment? I take a photograph. As I do that, I cannot see his pictures. My pictures taken would appear on my private storage. As I hand it back, it becomes associated with him again, with his me, and so we have the automatic transition of ownership, quote unquote, as we move around these us devices. And together we could form an ad hoc community, a wireless environment of a network community, or V for short. And then, of course, on the move or wherever we are, we want to use services back in the network that will probably be on different overlay networks and with different providers and so on and so on. So hopefully, here to the right, we'll end up with a free economy of services that we can move, that we can use on the move. Let's call these they. Okay, this is the global picture that we have, and now we try to work on many ingredients of this future vision. Like, for example, the underlying middleware that we call Mundo Core, like prototypes of this minimal entity. We call them talking assistants, like the context sensitivity location tracking systems that you need, like dealing with voice-centric input to the future internet on the move, like support for ad hoc community networks, like issues around ubiquitous security, like these digital identities, trust and reputation models, like shielding your software development from the variety of multimodal user interfaces the software will find available on the move, like context-aware service discovery and orchestration to deal with the they that you have seen to the right, like federated devices, making best use of all kinds of devices that you encounter on the move, and like Bionic approaches to dealing with all the data entry that you'll find if you keep, for example, your recording devices on all day. So this is the number of projects, and I hope to interest you in one or the other of them. So let me spend another couple of minutes just opening up one more level of detail for each of the projects, but still staying on the surface, but just as much as is necessary for you to understand whether it's of interest to your work or your research interest or not. Mundo Core, middleware for supporting all this. So this is the underlying thing that underlies everything here. How do you design it? How should this be built? Obviously, as I said, for scalability reasons, it should be based on the publish, subscribe, and event-based paradigm. It should be very small footprint because it should run, as we say, from server to sensor on very different sizes of devices. And you have to be pretty smart in that, may really modularize the system, really enable proxies like in a Zigbee Stargate network. You have the Stargate proxy for the very low footprint sensors. Enabling all of this is something that needs a lot of attention to build a proper middleware. So the core of it is publish, subscribe, and events. But then, as you move on, you develop software, you realize, now PubSub is gorgeous for open distributed programming, for really scalable programming, for not knowing which my peers are in the future. But then you realize you would love sometimes to have the old paradigms again. Just mentioning this last line here, we have interfaces to Java and to C++, and of course it turns out to be much more difficult for Java because moving from J2EE to a very small footprint Java implementation means you lose practically all of the support that Java claims to have, and coming up with a middleware that still gives you a harmonized API to everything you do is really a challenge on these. Oops, sorry. Now, as I said, rephrasing from what I said, you start doing publish subscribe and it's gorgeous, but then you realize you have some peers that you encounter on an event-based basis, and you want to establish a stateful, more permanent relationship with one of or the other of your peers, and you wish you'd have something like TCP streams or a remote procedure call, so you switch to this paradigm for some of what you're doing in your program. Then you realize, oh, I want to do some video streaming or audio streaming, and you have a third paradigm, namely streaming. And you end up with a mess in your programming environment. So a major challenge here is to really harmonize all three programming paradigms and offer to the programmer a similar way of approaching all three, so they integrate very nicely. And in addition, in a ubiquitous environment, you want to have adaptivity and quality of service support in a couple of ways. So this is basically what we did with Mundo Core. And the success story internally to my group is that the one who developed this got everybody on board. So all the other projects that I have cited in the slide before, they now all use Mundo Core. They started with different packages and APIs and whatever, and as they moved along, they found it so interesting, they now all use it. Period. Other issue. One of those who implement or leverage off Mundo Core. Prototypes for this minimal identity. Here another acronym comes in because we want to emphasize this voice-centric issue. Because we say this minimal identity may well be voice-centric. Because as you are working on the move, you want your hands and eyes free. So hands and eyes devices will not be the first choice for working on the move, you know. Rather, ears and mouth devices might dominate for many things that you do here. And of course, in the end, there will be a balance. But research up to now has not concentrated enough on ears and mouth devices to our opinion, so we just emphasize them for a certain time. And as you look at it, it's gorgeous what you actually can do with ears and mouth devices. There are different kinds of applications that all integrate very, very nicely if you just stick to voice for a certain time. And then, of course, as you need it, you add a screen real estate and even wall displays to what you do, but the core of it might well be voice. And if you look at how many things can be better supported if you have this little earplug that talks to you and that you can talk to, imagine how many users we could reach that are not IT users in their work environment today. People in hospitals doing patient monitoring and all kinds of things on the move. We can support them way more easily than we can with the current instrumentation with tablets and desk-side computers and all that. Imagine a shop floor in automobile production. I could talk an hour about how much productivity gain you could get from having people instrumented with proper variable devices there, and not HMDs for the first time, because HMDs require an awful lot of system integration cost. So it's really prohibitive for the lower workforce kind of environments where you have mass usage by thousands of people in your manufacturing plant. Laboratory automation, another issue where you could find these devices very nicely helping you. Intelligent buildings, support for pneumatic life. I mean, there are really many application scenarios out there where voice-centric applications make a whole lot of sense. So just one more slide on this. We built a number of prototypes for these talking assistants. We started with prototypes like this, where you see the location sensing system still, opened up. So this is really for a lab kind of environment. We put it into boxes in the meantime, and so this is a little more ruggedized. And of course, our vision of it is just an earplug in the future, but we're not there because we're not hardware people. We just build the stuff for experimenting and research purposes. So what is it that would go in a minimal identity? We have a strong belief. We have a lot of indications that these things would go in here, including some minimal kind of context sensitivity, even a modality for intuitive selection like head orientation or something, and we have built applications around that. It may be that they come in two flavors, one with absolute location awareness. Absolute meaning you have the geographic position where somebody is. So you have, quote unquote, the world coordinates where I am, and from that you infer that I'm in this lecture room. But for many purposes, you need relative location awareness. You need to know what's around me, And if these things are mobile, it is important that they are around me. I have this desktop at my disposal. I have the beamer at my disposal. That's the important thing, and not the fact that I'm in room number. I don't even know the room number that I am, in. So it isn't important for me. So it might not be important for my software. So this is the current rundown of features of the prototype that we currently use. And of course, we moved away from Bluetooth very quickly.
You said this is built over Mondo.
Yeah.
Is it a me, an us, or an it?
It is a me. Okay, we also build our own home-brewn infrared-based location systems. This is a stereo vision-based location system for absolute positioning. We build a number of badges and tags and room receivers and all kinds of things, all based on infrared, just to have our own environment. But in terms of Mundo, again, I think up to now we integrated something like 7 or 8 positioning systems, our own absolute positioning, our own badges and tags, UBSense, an ultra-wideband commercial location system, GPS, cell-based GSM location, an RF-based door opening system, and one more that, just escaped my list. So all these were very easily integrated with Mundo Core, and once you're there, your software can abstract from the specific positioning system and context awareness system that you have. Yeah.
Where did you move away from Bluetooth?
Why? Because it doesn't scale up to groups. Basically, if Bluetooth is by design something that replaces the cables on the desktop, so that the cables from your earplug to your memory box maybe, but not something where we cooperate in a wireless environment. It just doesn't scale up for many reasons. For example, if you look into decent audio channels, you're very restricted in the number of audio channels you could support in such an environment. And very easily in a ubiquitous scenario, you want to support tens of audio connectivity channels and things. So many reasons. And in terms of power consumption, it's not that much better than Wi-Fi anyway.
So by scale, you mean the number of nodes in one cluster? So
I mean, scalability can be attached to many issues, but basically, usually what I mean is number of nodes involved. Yeah.
But the thing is, why you're not doing like a Bluetooth to, for example, all these phones which going to be a Wi-Fi cell, and
yes.
From there you actually connect to this infrastructure called Mundo in order to actually create these groups.
Yeah.
And at that time you have still the one-to-one connectivity, which will be still Bluetooth based in order to do whatever you want to do.
This may turn out reasonable, to have just these US devices, for example, connect via Bluetooth to one hub that connects you to the rest of the world. Yeah, this may turn out to be the ultimate thing. For the time being, we don't want to integrate several wireless connectivity technologies, so we switch to this. Okay, and in the future, we think that only 2 local and 2 global positioning systems will survive anyway. And infrared may play a role in there. That's why we concentrate on it. Not many people are doing it. Satellite cell and ultra wideband are developed by other people. We also developed a pretty decent development environment for Mundo Core, where we support 3D world models for the absolute positioning kinds of applications that are very neat for visual development. Here in this example, you have a model of this massive, this mass of an office space. You have this person wearing a talking assistant or a me. That's the representation of the person, including the head orientation. And you have different areas that come as active spaces. So since he's looking at this active space that's in red here, that active space actually would talk to him. You have virtual walls like the one you see here that you need for hiding office spaces that can be looked at but don't make sense to talk to you if you're standing in this corner, etc., etc. Plus, we have a 2D, moving icons kind of thing, moving icons on a floor plan. You have seen this every once in a while, I guess. Other development systems have that also. We have a distributed debugging tool, special drivers, and so on. So it comes very nicely with a decent development environment. And maybe final part to be added to this. Imagine you're sitting at a desk. Tomorrow, Bill Gates forces you to move from Internet Explorer to Opera or something, just for comparison purposes. You'll easily find your way in dealing with it, because they're all same in terms of the basic functionality, basic way of how people interface or interact with the browser. Now, what's the equivalent to this in audio space, in speech space? What is a browser equivalent in speech? How do you build it? How do you structure information to comply with that? That's quite a research challenge. And in fact, we've done part of this piece of the research with SAP and come up with a decent architecture here about how you would structure that information, how you could get around this boring system reading out the menu to you, that we all hate when we do telephony applications, the system talking to us and explaining the menu to us all the time. This is not something you would like to use in a working environment. Rather, you would know, okay, you're at a certain part in the information space, and you have a number of navigation commands at your disposal at all time, to cut through the current documentation that's read out to you, to demand more information, to go in depth and higher up, and so on. So basically, it has to do with a very small limitation of our short-term memory that we have to cope with in audio browsing, and the limited set of commands that we can be trained to. So all this is also very important, because in such a working environment, what you have is a mixed initiative user interface. The context sensitivity should make the user interface be aware of what you're doing and deliver the right information at any given point of your workflow. But then if you want to take initiative and get some additional information or make this guy shut up or whatever, you want to take initiative. And for that, a kind of browsing metaphor is very important. So this terminates a set of projects that are very closely interrelated to one another. Now comes another project that's also based on Mundo Core, but has another, whoops, what is it doing here? has another issue it addresses. Remember our architecture, the wireless environment, people meeting ad hoc? For example, meeting on a commute or meeting because they're sharing the same working environment, because we are meeting today. Now, how would you build communities of such people very easily? And it basically boils down to just two data structures. I wish and I have. I wish expressing interest in information. I have expressing information or digital items that I can offer to you. May it be MP3 files, may it be information about restaurants in the area or whatever. And it builds on a one-hop network of people just encountering one each other. But of course, this is transitive. If I take in information that I gather from you during the talk, I go someplace else, and I take along information that interests me personally, then I can, spread this information at another place. The neat thing about this is that you have the personal encounter just at the side. So if something beeps and tells me, oh, wow, he got an interest in the same kind of music as me, he got some, nice concert in the area and I'm free tonight, we can immediately talk and switch to human communication based on what the system does in the background. Now, one of the fun parts of this is how do you, for example, develop a business out of that, First of all, of course, you have to come up with a decent ontology for describing the information that you're interested in or that you can offer in order to make open systems interact with this. So there is a model of how you would disseminate information, how you would describe when it's getting too old or not too many hops are involved, so you don't disseminate it anymore and all that. And there's a model for dealing with that. And how you deal with subcategories in a hierarchical information space and so on. Now, an interesting thing is, are there business models around such a network? And one of the business models we investigated and that brought up a very nice security issue was that of bonus points, You go to a store, you're interested in buying a DVD player, for example, and since this is on your wish list, you could suck in an ad from that store, for example. As you go to your workplace, you distribute these ads, and initially the ad would involve, say, 10 bonus points. And you can decide how many bonus points you want to keep, how many you want to share when disseminating. If you keep 4 and you disseminate the other 6, then the other 6 would be replicated to everybody who gets this information. And finally, whenever a purchase happens, you can trace back the chain of how the bonus points were chained to this buyer, and all the people on the line get their point rewards, So there are several purchases, you may end up getting multiple points and so on and so on. Now, the neat thing about this is it's a very interesting IT security issue, and it can be replicated to other somewhat similar business models that occur in community networks. So we just entered that space of how to make community networks a business of its own that is not dependent on central services. So this issue of ad pass turned out to be basically have two security issues involved: anonymity and privacy, but also this integrity protection over the recommendation chains, because you don't want to have somebody shortcut the chain and collect more bonus points, or the vendor get rid of some people in the chain, etc., etc. So you have to do this very neatly. And of course, most recently we entered the research field of trust models for the digital identities on our MEs or specifically on the talking assistants. Turning to yet another issue, as we all develop multimodal user interfaces, we are all faced with the problem of shielding the core development from, this goes on again here, shielding the core development from the different user interfaces that we want to support with our software. And many research labs have come up with basically the same solution to this. It drives me crazy here. Namely, to come up with a kind of very generic user interface that's modality independent, and then to map it onto the specific user interface that's available given the number of devices you have at your disposal. What our specific approach has, maybe as the single most unique point, is that we base much of this on hinting. Because everybody who has ever seen a user interface builder said, oh, wonderful, this guy have my user interface built for me, so a whole lot of hassle that I avoid. But now looking at this user interface, I don't know, it looks kind of ugly, kind of not really well designed, you know. So better not use a user interface builder, better handcraft the thing, you know. And we try to get closer to this problem by introducing hinting, so that a software engineer could give hints to the system about how to place the user interface elements either on the real estate or in the virtual space of audio or gesture or what have you as a modality. So this shows how from the logical widget to the embodiment on a specific set of devices, you have a number of functions that come in and determine which embodiment is actually picked then. And part of it is to the middle left, this hinting as an approach, you know. Closely linked to that is the issue of federated user interfaces. And we even try to team up maybe interest in the industry. So if you find this interesting, you could join our current trying to get together some industry partners on this issue here. Federated user interfaces, meaning and even beyond user interfaces, federated devices, meaning that on the move you encounter devices. You come in here, you have a number of very nice public displays available, large displays, but you only have got your little PDA or something. You want to make use of this. Now, on the other hand, Pat and I might look for a calendar entry for a meeting, you know, then our two calendars should show up side by side on this thing, but we still want to sit on the chair and the user interface should figure out that we can still use our PDAs for remote controlling the user interface. It should figure out that some of the data entries are too private to be shown in this setting, and then our boss comes in and even more things get grayed out. Federating devices is not a simple issue, you know. I just explained it for the issue of user interfaces, but you can you can enlarge that issue to all kinds of devices that you encounter on the move. You know, you may have a little personal server like the ones developed by Intel, or a future business iPod that stores part of your data, and that as you encounter other devices, does some neat things with these other devices. You may use them for purchasing things and have a digitally signed transaction record being exchanged. There's a number of issues involved in federating devices on the move, and at least a few of them could, you know, be launched as a very simple standard that somebody puts on the net and has everybody program against. So this is really a challenge for having this idea of all kinds of gadgets talking to one another, really get a move with a commonly agreed standard. Okay, I'll make this very short. The general idea is, what does it need on the THEY environment for everybody using services in a network wherever nomadic life happens? You know, me going from here to Singapore, trying to use the same kinds of services. What does that mean? How can I get guarantees about what the service is going to deliver? How do we negotiate upfront about the charges? How do we compare services in such a free economy of services in the network? What does it mean as a service infrastructure between the transport layer and the services layer? These are issues that we address in part in this project number 9. And the last one, Bionic data organization and interfaces. Microsoft has come up with the SenseCam idea, you know, and in fact, these recording devices have become so commonly available that we could figure we just leave them on all the time. Of course, we have to take care that they are, you know, switched off in some of the settings, but basically, why not leave them on? This is how our brain works. We have our eyes and ears on all the time. We wouldn't sit here, you know, and try to figure, when does Max say something important, and then we open our eyes and our ears to do a little recording and we shut them again. This is how we deal with IT devices today. We could leave them on and mimic the process of our cognitive system filtering out all the rubbish, you know, forgetting all that's not important, having fading memory of these recordings. And the same applies, by the way, also in a little bit a different approach to normal quote-unquote data. So mass data in an enterprise, for example, are collected and nobody knows what to do with it. So the data mining people, of course, have addressed this issue, but we want to address it from a bionic background. And we have come up, my goodness here, I don't know what made these keys here turn automatic. So basically, we have come up with 3 building blocks: the context-sensitive recording that gets us the necessary metadata, and then use the user interface for finding out how things are related in a meaningful way to the user. What does the user usually combine in his searches? And if you have a very flexible user interface, you will find out how he twists or she twists the user interface to display, for example, out of all the dimensions, display 3 dimensions that you can really look at as the basic coordinate system for organizing the data. If this is easily switchable, you figure out which are the data that are most relevant, and by that you can define proximity and the reinforcement of nearby data that's very typical in our brain, because we have this we have this functionality that nearby data get reinforced when we look at a certain item. You can mimic that very much based on the user interface. And then comes the consolidation. Do I delete or fade data that are not reinforced? How do I deal with that? With multimedia data, it's easy. I mean, you can lower resolution in time and space. You could just reduce to the metadata. You could, with other data, you could delete some of the columns in a record, you know, and just keep key entries or something, you know, or consolidate by just making an average, you know. All these are types of fading memory, you know. You have only a vague memory of what went on, you know. This is what you mimic, basically. So it's not a 0 or 1, keep or delete, but there's things in between. Okay, that was my talk. Let me give you a 3-minute trailer of other things that we do, just in case. Now you have the round picture of we do in ubiquitous computing. Just keep hearing this. I wanted to show you this today, but our attempt to make it gorgeous ended up in Windows deleting virtual drivers, so I didn't have the time to set it up again. But the pet has seen it, and the one who drives the system here has seen it. Digital lectures is a system that allows you to make, for example, this whole rear wall here be equipped with beamers, 3, 4, 5 beamers, how many you wish, and then use this as a kind of seamless environment. If you need to separate the beamers, like here, you can cope with it also, but most nicely you integrate it into one seamless environment, and then you divide that into tables, and PowerPoint can start to act like in any university in the world where you have sliding blackboards. From south of Africa to the North Pole, all universities since 200 years have sliding blackboards. Why don't we have that in PowerPoint, or in any other presentation software that we use? When I go to the next slide and you're still reading, you're lost, And this is just one of the features of the digital lecture halls. Many others, basically. I don't want to go into detail, multi-perspective videos, support for learners in the loop with different device classes ranging from cell phones up to tablet PCs and laptops. Input devices for the teacher being Wacom tablets, tablet PCs, smart boards, and so on. And basically 3 groups of functionality. The presentation and annotation support on the top, the interaction support for both spontaneous interaction and planned interaction, and the recording and rehearsal support to the lower left. So the different interaction modes, most of them are so simple that you can support them on a cell phone. Some of them are more sophisticated, like broadcasting all the slides and all the events in the system. And there is symbol recording that just delivers an MPEG-4 stream, but also more sophisticated recording for perpetual note-taking, where you can add sophistication as you learn about the subject. So many things like that. This I'll just skip. And then e-learning and ubiquitous computing have a lot in common if you talk about ambient learning, learning that disappears in work life and everyday life and has a huge potential for industry. So this is where my 2 research branches get together. Just to show you that we did more in user interfaces, for example, video interfaces, how to arrange video keyframes on the real estate of monitors. In the upper right example, we just showed what it means to get rid of the background, how you can nicely display dynamics in a video with keyframes. This shows 2 different ways of building 3D worlds. This looks like a mess, but in fact it's gorgeous, absolutely gorgeous. Think of Reuters submitting 100 hours of video every day, and you having to pick the one clip for the newscast in the evening. So you're supposed to go through 100 hours of video in 1 hour maybe. How do you arrange the keyframes visually on the screen? And we did a very nice implementation where you could fly through that. And it is based on the original idea of cone tree interfaces. Most user interface people know that old idea. It didn't pay off because on cone tree user interfaces, you got to read the menu entries anyway. So you go through sequentially. It doesn't give you a lot of advantage to have them all displayed at once. Now with keyframes, you can make take full advantage of the cognitive system's ability to compare and differentiate keyframes very quickly and to orient in space. So this turned out to be a gorgeous interface to video editing that we even turned into a version for direct editing in a cave that would be very suitable for digital video production. Another thing runs in several tech museums in the world where you can conduct virtual orchestras. So using a conductor's baton, you can conduct canned orchestras and develop the speed and volume, velocity and volume of the orchestra. You can turn to specific orchestra groups to highlight them. All kinds of features for of virtual conducting implemented there. And finally, we also contributed to the kinds of comic actors on the screen types of things with a little bit of twist that hopefully was an add-on to what Microsoft offers with their technology. Okay, so this was the quick rundown of other things that we do and that are not related to the talk as such. I think I made my 1 hour.
Thank you very much.